Okay, we are still factoring and using the zero product property to find the solutions to the quadratic equations. So let's take a look at this first problem here on 2C. If we take a look, we can notice that this is actually one of our patterns. So our pattern here is a difference of squares. And we know that the difference of squares we take the square root of the x squared term, so 1x squared, the square root of that would be x, so we put the x here, and then the square root of 9 is 3, so we have one term that's plus 3 and one term that's minus 3. Now, we could have done this problem using a diamond and generic rectangle. It would get us the same answer. So we can take a look at what we would have done. Okay, so remember our format is ax squared plus bx plus c equals 0. So in this case, our ax squared term is just x squared. And our c term is negative 9. So when we multiply them together, we get negative 9x squared. We have no b term, which means it's 0. There are 0 x's in this problem. So what multiplies to a negative 9x squared and adds to 0? We know that 3 times 3 is 9. So if we plug in a negative 3x and a positive 3x, they multiply to a negative 9x squared and they add to 0. The only way for two things to add to 0 is if they are the same absolute value, but they have opposite signs. So the positive 3 and the negative 3. So negative 3x and negative 9 have a negative 3 in common. X squared and 3x have x in common. X squared and negative 3x have x in common. And 3x and negative 9 have a positive 3 in common. We can check all of this. X times x is x squared. Negative 3 times x is negative 3x. X times 3 is 3x. And negative 3 times 3 is negative 9. So we did, in fact, get the same answer. So we have an x plus 3 times the quantity x minus 3. Now, we still have to use the zero product property to solve this. So we've got x plus 3 equals 0. We're going to subtract 3 from each side of this equation. We end up with x equals a negative 3. Do the same thing with x minus 3 equals 0. So we add 3 to each side in this case. So we're just solving it. That's what I mean by doing the same thing. They're not the same equations. We don't solve them exactly the same way, but we are going to solve it. In this case, since we added 3 to each side, we get x equals a positive 3. So our solutions, our roots, our x-intercepts for this quadratic equation are positive 3 and negative 3. But just to clarify, you didn't have to do the diamond and generic rectangle on part C if you recognized that it was a difference of squares. So you could have recognized that it was a difference of squares and used the pattern to get your products. Then you would have used the zero product property to find the actual roots. Okay, let's finish up with part D. So we double check it is in the correct order, ax squared plus bx plus c. So we want to make our diamond and generic rectangle. We have x squared. We have 36. So x squared times 36 is 36x squared. Our bx term is 12x. So we need to figure out what two things multiply to a positive 36x squared and add to a positive 12x. Well, again, if we didn't know, we could list all of our factors. This one is in our multiplication table. So 6 times 6 is 36. And 6 plus 6 is 12. So this is going to be 6x, 6x. They're both positive 6x. So now we pull out what they have in common. So 6x and 36 have a 6 in common. X squared and 6x have an x in common. X squared and 6x have an x in common. 6x and 36 have a 6 in common. Double check all four boxes. X times x is x squared. X times 6 is 6x. 6 times x, 6x, and 6 times 6 is 36. So this works. Okay. So now we have our factors as x plus 6 times x plus 6 equals 0. Well, x plus 6 is the same as x plus 6, so we actually end up with x plus 6 quantity squared equals 0. Now, you may have noticed that this is actually our perfect square trinomial. So you could have identified it as a perfect square trinomial. X squared is perfect square because the square root of 1x squared is x. And 36 is a perfect square because 6 times 6 is 36. So you could have identified it as a perfect square trinomial, in which case you would not have had to have done the diamond and generic rectangle. Now, we know that both factors are the same, so we only have to solve it once. We've got x plus 6 equals 0. So we're going to subtract 6 from each side of our equation, and we get x equals negative 6. So our final answer is x equals negative 6. Both roots give us x equals negative 6. It means that this parabola only touches the x-axis once at a location of x equals negative 6.